Good day, everyone. My name is Nautrunagamage Chamode Harshini Prasangika, and today I will be presenting my network design proposal for a university research and innovation center. This project is part of the Computer and Network Security module, and the objective is to design a network that is not only functional but also scalable, secure, and suitable for a modern research environment. In this presentation, I will first explain the scenario, then analyze the network requirements, followed by my proposed network design, implementation approach, and finally conclude with the key outcome. When we talk about the scenario, the university is expanding to a new four-floor building, and each floor has different operational requirements. The ground floor includes reception, IT support, and seminar rooms, which requires stable connectivity for administrative tasks and presentation. The first floor contains faculty offices and open plan research workstations, meaning a large number of users will be connected simultaneously. The second floor includes laboratories with multiple research stations, which generate significant data traffic due to experiments and data analysis. Finally, the third floor includes a high-performance computing lab, servers, and collaborative student workspaces. This area is particularly demanding in a term of bandwidth and performance. Therefore, the network must be carefully designed to handle uh, diverse and intensive workloads. So, when we talk about the network requirements, based on the scenario, several key requirements were identified. Firstly, the network must support a large number of users and devices across all floors without performance degradation. Secondly, high bandwidth is essential, especially for laboratories and the HPC environment where large data sets are processed and transferred. Security is also a critical requirement because sensitive research data must be protected from unauthorized access. Additionally, the network must be scalable so that future expansion, such as adding more devices or departments, can be accommodated easily. Finally, both wired and wireless connectivity are required to support different types of devices, including desktop computers, laptops, and mobile devices. When we talk about current LAN design, local area network design, this slide shows the current LAN design based on the given scenario. The existing design mainly consists of switches connecting devices across different floors. While this basic structure allows communication between devices, it lacks a clear hierarchical organization. One of the main limitations of this design is that it does not efficiently manage network traffic. As the number of devices increase, the network may experience congestion and reduced performance. Another issue is scalability. Without a structured design, it becomes difficult to expand the network or troubleshoot problems effectively. Additionally, the current design does not clearly separate different network segments, which can lead to security risk and inefficient data flow. Therefore, improvements are required to enhance performance, scalability, and overall network management. So here is my proposed network design. To overcome the limitations of the existing network, I proposed a hierarchical network design. This design introduces a router connected to a core switch, which acts as the central backbone of the network. Each floor is connected through distribution and access switches, allowing better organization and management of network traffic. Wireless access points are also included to provide Wi-Fi connectivity for users with mobile devices. This design ensures efficient communication, reduces congestion, and allows easy expansion in the future. So let's talk about network architecture. The proposed design follows a three-layer hierarchical model. The core layer is responsible for high-speed data transfer across entire network. The distribution layer connects different floors and manages routing and traffic control. The access layer connects end devices such as computers, servers, and wireless access points. This layered approach improves performance, simplifies troubleshooting, and enhances scalability, making it suitable for enterprise level environments. So, when we talk about the devices I use, the network uses several key devices. The router connects the internal network to external networks such as the internet. The core switch acts as the central communication hub, while distribution switches connect each floor to the core. Access switches provide connectivity to end devices. Wireless access points allow users to connect without cables, increasing flexibility. Finally, servers and PC represent the end user devices that generate and consume data within the network. So, when we talk about IP addressing, I used a Class C IP addressing scheme because it is suitable for medium-sized networks. Each floor is assigned a separate subnet, which improves organization and reduces broadcast traffic. For example, the ground floor uses the 192.168.10.0 network, while other floors use different ranges. This structure makes it easier to identify devices and manage the network efficiently. So, when we talk about implementation and testing, after designing the network configurations were applied to devices such as switches and PCs. IP addresses and subnet masks were assigned and connectivity was tested using pin command. Two scenarios were tested: communication within the same subnet and communication between different subnets. Both tests were successfully confirmed, meaning that both tests were successful, confirming that the network supports both local and internet work communication effectively. So, in conclusion, the proposed network design provides a reliable, scalable, and efficient solution for the university research center. It, it supports high-speed data transfer, secure communication, and flexible connectivity for different types of users. The hierarchical design ensures that the network can grow in the future without major changes. Overall, the project demonstrates how proper planning and structured design can significantly improve network performance and usability in a real world environment. So these are my references list as you can see. And this is the end of my presentation. I hope you got will understand about my proposed land design, network design. And thank you so much for your time.